Let's do part B. Calculate a power of 11 where a is this. One method, you can just take power 11, multiply this matrix 11 times. But it will be very long, so don't do this. So what can we do? We can make use of the result from the previous part. But it requires us to have a that is diagonalizable. If a is diagonalizable, meaning that I can find my p that diagonalizes a, so a to the power of 11 will be p d power of 11 p inverse. Okay, so let's do this. So to find p, I need to find the eigenvalues and their corresponding eigenvectors. So I first consider 0 equals to lambda I minus a. Okay. So this is lambda plus 1 minus 7 plus 1. Sorry. 0 lambda minus 1, 0, 0 minus 15 lambda plus 2. And we compute this by doing cofactor expansion on this column, and I will have lambda plus 1 multiplied by determinant of lambda minus 1, 0 minus 15 lambda plus 2, and this is just lambda plus 1 times lambda minus 1 times lambda plus 2. So lambda is equal to minus 2, or lambda equals to minus 1, or lambda is equal to 1. Next, what I need to do, I need to find the eigenvectors. Okay, for this, and for this. So for lambda equals to minus 2, we want to find x that is not 0, such that minus 2i minus a x is equal to 0. In other words, this is what? Minus 1, minus 7, 1. Sorry, yeah, correct. 0, minus 3, 0, 0, minus 15, 0. Okay, multiply by x1, x2, x3 equal to 0, 0, 0. Okay. This means what? The first row gives us minus x1 minus 7x2 plus x3 is equal to 0. The second row gives us minus 3x2 is equal to 0. The third row is minus 15x2 is equal to 0. Okay. From here, we can see that x2, oops, it is pink. From here, we see that x2 must be 0, which is consistent with this, right? So I must have x2 is equal to 0. And if x2 is equal to 0, this is 0, so I will have x1 is just x3. But I can let one of them to be free parameter. Okay, what I mean is this. Then, because this x1 is just x3, and x2 must be 0, but there is no restriction on x1 or x3. So I can make this x3 as a free parameter, and this x1 just follows. So x1 will be t. Okay, where t is just a real number. So my x is t times 1, 0, 0, where t is a real number, and we can pick this as my eigenvector for lambda equals to minus 2. Next, still have two more. So for lambda equals to minus 1, we want to find x not 0, such that minus I minus a, x is equal to 0. In other words, 0 minus 7, 1, 0 minus 1, 0, 0 minus 15, 2, sorry, this one, times x1, x2, x3 is equal to 0, 0, 0. The first row gives us minus 7, x2 plus x3 is equal to 0. The second row gives us minus x2 is equal to 0. Then the third row is minus 15x2 plus x3 is equal to 0. Okay, and we see here this x2 must be 0. And if x2 is equal to 0, so this will disappear, my x3 must be 0. And if x2 and x3 are both 0, this is satisfied, right? 0 is equal to 0. And we don't care what is my x1, so we can make our x1 to be free parameter, but both x2 and x3 must be 0. So I found my x is t times, sorry, this is t0t, so this should be 1, 0, 1. Okay, here is 1, 0, 0. And we can pick this as the eigenvector for lambda equals to minus 1. Okay, last one. So for lambda is equal to 1, we do the same thing. We want to find x that is not 0, such that I minus a, x is equal to 0. In other words, okay, we'll have 2 minus 7, 1, 0, 0, 0, 0, minus 15, 3. x1, x2, x3 equal to 0, 0, 0. Okay, so this I will have 2x1 minus 7x2 plus x3 is equal to 0. The second row is just 0 equal to 0, so I don't write it out. Then the third one is 15x2 plus 3x3 is equal to 0. Okay, this looks a bit complicated, right? So you can try to write this in terms of augmented form, okay, and find the reduced row echelon form, or sorry, row echelon form. But you can also do it this way. Okay, let's just do it this way. I have what? How to do this? We see that if I make this x3 as a free parameter, then I can express x2 in terms of that free parameter. After that, x1 I can express in terms of x2 and x3, but x2 and x3 we can express in terms of that free parameter. So it should work, right? So let's make x3 to be t. So x2 is just 1 over 5 of x3. So x2 will be 1 over 5 of t. How about x1? x1 is 7 over 2 of x2, which is 1 over 5t, minus half of x3, half of t. So this is what? 7 over 10 minus 1 over 2t. So this is 5 over 10, 2 over 10. So this is 1 over 5 t. Okay. Yeah, should be correct. Where t is real numbers. So I have my x is just 1 over 5t. Sorry, make it smaller. 1 over 5t, 1 over 5t, and t. Then I take out 1 over 5t. So I will have 115. Right, t is real number, and we can pick this 115 as our eigenvector for this eigenvalue. Okay, then this, okay, we only have the set of this eigenvector. There is only one element here, so of course this is linearly independent. This is also linearly independent. This is also linearly independent. So the union of these three, okay, is linearly independent. Since what is that? Let me pull this up. 1 0 1 1 0 0 and 1 1 5 is linearly independent. And there are three elements, right? There are three of them, okay? So we can find P. We have P, okay, let's write in the middle. P, just write this as a column vector 1 0 1 1 0 0 1 1 5. Okay, diagonalizes A. Okay, then after this, what we need to do, okay, diagonalizes A, and my D, okay, and D, which is P times A times be so long. Okay, continue. Sorry, P inverse AP. This is what is my eigenvalue? Minus 2, minus 1, and 1. Minus 2, minus 1, and 1. 0, 0, 0, 0, 0, 0. Okay. So now, okay, hence, okay, next week we are not done yet because to find a, okay, to find the a power of 11, I need p d power of 11 p inverse. Okay, we have found our p. D to the power of 11 is quite easy because d power of 11 is just minus 2 power of 11, 0, 0, 0 minus 1 power of 11, 0, 0, 0, 1 power of 11, which is 1. Okay, so we already have this, but then we still need to find P inverse. Okay, I'm sure you can do P inverse. Okay, so I will just skip that, and hence, okay, I'll just copy the answer. A to the power of 11 is just P d power of 11 P inverse. Okay, so you do metric multiplication, this times P inverse. Okay, so I will have, I'll just copy the answer, minus 1, 1, 0, 2, 3, 7, minus 2, 0, 4, 7, 0, 1, 0, 0, 1, 0, 2, 4, 5, minus 2, 0, 4, 8. Okay, but yeah, from here to here, I need to find P inverse. Okay, it is still very long. Okay, it took me 18 minutes. And then you might say that if I compute this manually, maybe it is faster, right? But then imagine if this is not 11, let's say this is 5,000 or maybe 10,000, right? By using this method, the length, okay, the process is the same, okay, and it will only take you 18 minutes, okay. But if you want to compute this manually, it will be very long. Okay, good. This is not very difficult, but it is very long. Okay, please be careful when you do the calculation. Okay, hope it is clear.